Morning everybody, welcome to PyCon. My name is Jamie Lennox and I work for Red Hat here in Brisbane. I've been doing OpenStack for about 18 months and I'm a core member of the Keystone team and do a fair bit of work around the various Python libraries for the services. Today we're looking at federated identities and Keystone. Okay. So apparently we all know a little bit about OpenStack at least. I had the standard Keystone introduction. Keystone is the part of the cloud that provides your authentication and discovery. It's generally the first point of contact. You submit your credentials to Keystone. For the presentation, we'll just use username and password. And you get back a token containing your permissions within that cloud and a catalog of the different URLs that you can access using that token for all the different services. So standard token flow. A user here submits his password to Keystone, gets back a token, and whenever he goes to talk to Nova, Glance, insert service, he submits a token and it says, Keystone has said, this is what I'm allowed to do, you don't need to re-authenticate me. So the security advantage is that username and password is only transmitted once to Keystone, and everything else just works with the token. If your token gets intercepted, that's still bad, but your token lives for, by default, about an hour. Your password can live until you change it, so the interception risk is much, much less. So there are two major jobs to Keystone's token issuing, and the difference between authentication and authorization is a fairly important one. So authentication is just looking up who the user is, taking a username and password, matching that to a user in your database, and verifying that the password is correct. That's all authentication does. Authorization is then the process of taking that user and figuring out what they're allowed to do within OpenStack, what roles they have, what projects they're involved in, all of that sort of work. So typically in sort of a large-scale deployment, we'll say that authentication should be coming out of LDAP or something. It's probably coming out of an existing identity store. And your authorizations should be managed by Keystone or probably within a SQL database. And if you look in Keystone, they're not called that, but we have authentication, which is the identity backend, and we have authorization, which is the assignment backend. So that structure is fairly well followed. Putting that aside for a second, federation, for us, or for our context, federation is the ability to use a person's externally managed identity within Keystone. So you've probably seen when you go to a website and you're asked to create a new account or to sign in, you're offered a list of you log in using your Google account, log in using your Facebook account, some other, some existing identity that you have. And the concept here is exactly the same for what we're trying to do in Keystone. How do we take those users that already exist in an external identity provider and use them within Keystone and within our cloud? So firstly, what is the advantages here? Like why do we want to go down this path? So the obvious one is convenience. Users already have a bunch of credentials. You've got username and passwords for just about every site. They don't really need another one, particularly if you're looking at sort of deploying private clouds. You've already got your enterprise login, your company login. You don't need another one just for your cloud or just for OpenStack. And convenience for the admins as well. Every time you've got something that manages passwords, you've got password resets to manage. You've got to make sure that password rotation policies match whatever your corporate sort of structure is. So that all exists. Managing that sort of identities, that's out there. We don't really want to reinvent that wheel. Integration. So as I said, enterprise, you've probably already got some form of either single sign-on identity store. At the moment, we can access a lot of that using LDAP. But there are still specific, there are companies or there are structures where the schemas are different. LDAP is a pain to manage. If you've got a single sign-on, we want to reuse that in Keystone rather than have all of our own structures. And partnerships. So a public cloud, you've got two different companies that want to work together, form a joint team. either somebody has to create users for your other partner company, or better would be just to map both of the existing identity providers into Keystone so they can both work in the same space. Migration, particularly if we're talking public clouds, if there are 5 or 6 public cloud providers and they will all accept your Google ID, you're going to start seeing much better movement across clouds. You're going to start, this cloud is particularly good for this job, this cloud for this job. If it's all using the same credentials, we sort of hope that you're going to get a lot better migration across them. And security. Every time you create an identity store, that's another place that can be compromised. There's a set of processes that you have to make work. There's another database table, another chance that your company can end up in the news for dropping its table all over the internet. So we definitely don't want to be that. We can never get away from what we've got. Like, we will always have to have some internal support, but yes, hopefully. We're probably talking at least 3 or 4 cycles, but yes, will it be the default? So, same diagram. The federated world, we've got 2 types of providers, or two services. The identity providers, which I'm probably going to call IDPs at least once, they're the source of identity. They're storing a user, they're storing the password somewhere. And then the other side of that is the service providers, and the service providers are the consumer. They want to provide their service, they want to know that the person that's logging onto them is authenticated, but they don't want to manage their own user table. That sort of stuff should be given to them. And so, same diagram from before. This is Keystone as an identity provider. We are storing passwords in a database. What we want to do is get away from that, like have that managed by somebody completely else. So this is what we're looking for. This is our goal model. So your user authentication is handled by some completely other identity provider. That can be Google, Facebook, your enterprise accounts, anything. Then Keystone is a service provider, the service of issuing tokens and the authorization of what can happen within your cloud. So we take that user and we still need to look up the roles and stuff in Keystone to figure out what that user can do. So Keystone is not becoming obsolete. It means that it's a boost to performance. We're running behind Apache. Any crypto in terms of identifying and validating the IDPs, handled in C. It's a boost to security. We're looking to use standard existing Apache modules. We don't need to implement that ourselves, so they've been battle tested. And for any of the developers in the room, running behind Apache means Keystone no longer has to deal with eventlet, which is a massive win for us. So to get there are a couple of competing standards. OpenID Connect, there's a newish one called AbFab, but the most common, and particularly in the enterprise space, the most common one is SAML. So SAML's an open standard and XML-based protocol. It came out of one of the Oasis groups about 10 years ago, and it's had a number of sort of improvements since then. It transmits both authentication and authorization data. So what that means is that the packet that we get from a SAML provider contains not only who the user is, but all of the roles that IDP knows about that user. So for anyone that's familiar with, say, the OAuth flow, OAuth will only give you delegation. It says this user is allowed to access this service, but it doesn't tell us anything more than that. In Keystone, we need to know what roles you have so that we can turn them into something useful. So it was designed as a browser-based spec. Your user goes off to the service provider, says, give me this resource. Service provider, probably Apache level, it never actually gets into the program. Apache will say, this is an authenticated call. You need to go and log on to this IDP. It'll give you a browser redirect and over to the identity provider, and you'll get the standard, hey, log on with your password. Do you want to allow Keystone to have access to this information? Assuming you say yes, it returns the response. And we typically call the response, at least in the SAML case, an assertion. This is what the IDP asserts about the user. This is what we know about it. So it returns the SAML's assertions, and via the browser redirects, gets back to the service provider. This time, service provider says, yep, that's cool, and returns the response that you initially asked for. That's, as I said, SAML specific, but all of the providers that do this work in a fairly similar flow. This is a small chunk of what SAML looks like. And if you can't read the little bits, it doesn't matter. It's just, this is what happens when you let committees design XML specs. That is a 2-item list and a key value pair in XML. So it contains, obviously, you can see in highlighted, you've got 2 roles. It's got, which is your authorization data, and it's got surname Lennox, which is an authentication information. Along with a bunch more of these, it's got some basic restrictions on like how long the SAML assertion is allowed to live for, who the service provider is allowed to be, that sort of thing. So Apache gets this snippet and parses it out and throws it through to Keystone. So Keystone never needs to see this. We don't have to deal with XML at all. And if you wrote a small PHP script that dumped out all the environment variables, you would get something that looked like this. Now, in this case, the module that I was using to parse the SAML is called modmelon. That's what the melon prefix is for. It doesn't always happen like that. There are other modules that you can use. It doesn't matter so long as that data comes through into Keystone. So there's a lot of information there. You don't need to read it all, but you can sort of see that the surname has come through, and there's a few other important fields like the UID, which we're probably going to want to use. So now we've got all that. That's coming through in our environment variables on a per authentication request basis. And it's unique to the IDP. How do we convert that into something that Keystone is going to understand? And the answer is essentially a mapping table. If Keystone's job now, or in this federated case, is going to be to take those existing credentials and turn them into something local, turn them into a token that OpenStack can use. Now that's not overly easy. You can have the case where you've now got multiple identity providers all existing within the same cloud. And each IDP will define their own roles that mean something specific to that IDP. You can have 2 IDPs mapped in, and each of them has a staff role. But one of those is staff at a 50,000 person company, where staff gives you pretty much nothing. The other is staff at a small startup, where staff lets you create projects and delete users and all sorts of other things. You can't just one-to-one map those roles. So yes, our mapping table is a series of rules on a per IDP, per protocol on the IDP basis, which says the presence of these attributes coming in from the remote IDP link to or create this user within Keystone. Now, that's great, but we have a problem because now these users, they don't exist in Keystone. They're ephemeral. They've been created essentially for the purpose of this. We don't take that data and then store it in our database. It sort of defeats the purpose. But the standard way of assigning permissions in OpenStack is you take your user ID and you assign a role to it in a project. If the user doesn't exist, that breaks down. So what we have and what we're left with is the groups. And groups have been around in Keystone for a while now. And a group can be assigned permissions can be assigned roles in a project such that all of the users within that group also inherit the roles from that group. So the standard flow would be, for an administrator, you create a bunch of groups that make sense and you assign the roles to them. And what we're trying to do then is map these ephemeral, the sort of fake users that are coming in from, they're not fake, they just exist externally, map those users into the groups so that we can get roles out of them. So to do that mapping, we get things that look like this. That's one JSON packet, or one JSON segment just sort of split in two. A list of rules, and each rule is a dictionary, and it contains a local part and a remote part. So in this case, we're looking for this rule matches you need to have coming in from the IDP, and I've stripped out the melon prefix. It has to have an attribute of a given name, a surname, a UID, and it has to have a role. And role has to match staff, and surname has to match Lennox. That's a pretty useless rule in a real sort of production system, but it works for what we've had in the previous few slides. If all of those things are present, then on the local side, we construct a user, and the format string is essentially pull that information out of remote. So 0 will map to given name, 1 will map to surname. That's how it constructs your local user data. And importantly, a list of groups, because your groups already exist. They do exist in Keystone. With that user and group information, we're at exactly the same point as we would be had we pulled that information out of the database. So you take that information and all of a sudden you start assigning roles. That goes into your token. The rest of OpenStack doesn't have a clue how your user actually authenticated. Okay. This is some of the more depths of how you access all of that information and how you would go about setting it up. You need to create an IDP. Everything I'm talking about is done under the OS Federation extension within Keystone, and that's where the prefix comes from. You create an IDP. You need to create a mapping for all of those environment variables through to Keystone. And you assign that mapping per IDP per protocol. So what that means is your IDP is your external provider. It could be Google, it could be your enterprise. And then the protocol is the way that that provider talks to you. So your protocol could be SAML, AbFab, OpenID, I've mentioned already. So you can have multiple protocols per IDP, but the mapping exists per protocol. And then when you want to get a token, you have to come to this longer string and get it specific to that auth type. So in a standard flow, it means we're going to have some discovery of what ID, or how do I log on to this service. Okay. So where are we? It works. It does. You might have seen there's been some press coverage recently, particularly coming out of CERN and out of Rackspace, about the federated identities they've got working in the CERN labs. And this is what it's all based upon. There are some caveats to that. The main one being ECP is a profile of SAML. It stands for Enhanced Client or Proxy, which tells you nothing about it. As I said, SAML is particularly a web-based protocol. It was designed as a web-based. It expects you to be able to bounce around via a browser and have links that you can click on and places for you to enter your password. That doesn't really work for us in most cases. So ECP is the same SAML protocol, but from a non-GUI perspective. So you can use it from a command line or from sort of stored applications. Unfortunately, ECP is fairly rare in actual production. It typically means that somebody in the organization has already said, oh crap, SAML doesn't work for our case. We need to install ECP. So unless you've hit that case, you probably don't have ECP enabled. And the client side of all of this, on the IDP. So the IDP has to say, yes, I accept. Because when you configure ECP, you can say, you still need to do an authentication step. So do I want to authenticate over basic auth? Do I want to authenticate over client cert? Within that, there are still a bunch of different ways you can actually authenticate to the IDP. And the client side of all this is still in review. So all of those routes I mentioned, they work and they exist. But if you want to use it today, you're pretty much constructing all of those JSON packets yourself. In the case of CERN, they've got a whole team there whose job is to make this stuff work. they can do it, but we're still filtering through the authentication plugins and stuff to have it user-friendly. But what I think is interesting from all of this is the framework and the mapper. Given we've now got this base, we should be able to turn pretty much anything that comes in from an Apache module, and there are a bunch of them for just about any sort of authentication mechanism you want. We can turn that into something that makes sense in a Keystone perspective. So we can support a couple, and then it can be up to the implementer to figure out exactly what protocols that they want to implement. So the top one, anything you can map. The top one is OpenID Connect. That's fairly high on our priority list. There are blueprints, and I think there are even a few reviews going through at the moment for working with OpenID Connect. Mod Identity Lookup backs to FreeIPA and backs to SSSD. It essentially lets you do a lot of things like looking up your LDAP tables from Apache and pumping all that information through, which is a huge win, because for us, managing LDAP stuff in Python is a massive bottleneck and a pain. So if you can get that stuff out, that's amazing. AbFab is relatively new. It's fairly important to a couple of the universities and stuff around sort of the European area. That's slowly progressing. But the point is you can do pretty much anything. I mean, Modauth Curb is Kerberos, Modauth Digest is basic auth. They don't give you much beyond a username when you authenticate with those. But if you set up your mapping rules, if that's all you need, you can map that into something in Keystone and never have that user exist. But what I think is going to be the most interesting one is Keystone to Keystone Federation, which is Keystone acting as an identity provider for another Keystone. So take, for example, you've got your private cloud in your company, and you want to send off to a public cloud to do a certain workload. You take your private cloud's token, you send that to the public cloud and get a new token that lets you work in that cloud without ever having to go back and get new credentials, get new information. They will work together and they will recognize each other. Because again, all we're doing is mapping roles that exist in one Keystone into roles that exist in another Keystone. And that's essentially the basis for a lot of this hybrid cloud promise that has been coming, but has never quite got here. Once you've I think once you've got that, you start seeing a lot more single login working across multiple clouds that are sort of linked together. So I think that's probably the most sort of exciting of where this is going. So as all OpenStack projects, there's a lot of fingers in this pie. Particular mention from this list are the team at CERN and the team at the University of Kent. They've done a lot of, probably most of the design and implementation work around Federation. And obviously the CERN guys are actually trying to put this into production as quick as possible. That's me. I'm around for the